Hello. Good afternoon, everyone. It's time, so we are ready to begin. So before we begin, please confirm that you can hear me and see the slides clearly by just typing yes in the chat window. Also, I would like you to introduce yourself, your name, your designation, company, and the country you are based in, so that we get to know our audience. It's a pleasure to see an international audience of people from all industries and background. Good to see you all. Great. And thanks for confirming. We are receiving your responses. I would like to thank you all for registering and taking time out on a Sunday to learn about case study presentation for ASME B31.8 API 1160 based PIMS software for cross-country pipelines. My name is Aisha Khalik and I will be your introductory speaker for today. It's our pleasure to host this webinar for you. For your information, this is our 81st webinar in a series of technical webinars that we are conducting. As a practice, we are conducting one webinar every month. Please follow us on LinkedIn and YouTube and make sure to check our website for the latest updates. Today, we have an experienced panel of speakers with us. I am with my colleague, Mr. Ijazul Karim Rao, Managing Director, Principal Integrity and Safety Consultant, Madam Mubina Khatun, Director, Engineering Services, and Mr. Anthony James William, General Manager, Global Sales. Moving forward, during this webinar, we encourage you to keep asking questions to clear any doubts. We would definitely like your engagement on this topic. You can type your queries in the question and answer window, and you will receive a reply in the question and answer window, or we will answer it live. We will try to answer questions as much as possible during this session. As we will have a detailed answer and question session after the completion of the topic, please accept our apologies if your question is not addressed. Due to high volume of questions we usually receive, we have to be selective. Furthermore, we will also be issuing participation certificates to all those who have completed at least 80% of the webinar and have participated in the discussion through question and answer. Since this is a quite technical subject, we will touch only the theoretical and practical aspects of case study presentation for ASME B31.8 API 1160 based PIMS software for cross-country pipeline. Our agenda is to cover what is asset integrity, overview of pipeline integrity management system, PIMS, regulatory and industry standards, overview of ASME B31.8S 2018 and API 1160 2019. Then we will cover AIMS system and framework, PIMS framework and manual, and PIMS software sample. In this limited 2 hours, we request you all to follow along with us and keep asking questions to help us make this session as engaging as possible. And before we begin, let's have a safety moment. Almost most of us are in the comfort of our homes. We should be aware of emergency exits. We should keep a safe distance and generally take care of people around us. So from now on, I will ask Mr. Ijazul Karim Rao to start with today's topic. Thank you.
Assalamu alaikum and good day, everyone. Today's topic is related to pipeline integrity management, and this interesting topic for the cross-country pipelines. So it is not a piping, which is a plant piping. It is a cross-country pipeline, like a gas carrying pipeline from one country to other country, like from Russia to Europe or from Azerbaijan to Italy or other countries. So before we go to the topic, the first question is like, what is asset integrity? So asset integrity is normally defined as is a continuous process, like first of all, and from the birth to the grave, like at design stage, at operation stage, and also during the construction and design stage, like if I have to focus myself. So it is normally, okay, so I'm not actor, that's why, so the new camera is there, sorry for this. Okay, so let me define the basic definition point of view. This asset integrity, design integrity, technical integrity, and operational integrity. And design integrity mean if the things are designed in accordance with applicable code standards, and then technical integrity mean if the inspection and maintenance activities are done as per the due standards. Then operational integrity is operating the facilities in accordance with the applicable operating limits, or IOWs are maintained as per the operating parameters of the facilities. Then pipeline integrity is like, as such, pipeline is simpler than a plant, because in plant there are many complications are there, various temperatures are there, various reactions are there, reactors are there, burners, heaters, boilers, and various kind of reactions take place in the plant. Whereas in the pipeline side, mainly we transmit fluid from one end of the area to the other end. So it's only a pumping for the liquid, and compression for the, basically for the gases. And then it is a one pipeline which is going kilometers and kilometers, and fluids are transmitted under the fluid head. However, as the pipeline is going from one area to other area, then there are pressure changes, there are fluid composition will remain same, more or less same, but it will have some erosion effects inside. There could be bacterial growth inside the fluid, but there's an external environment which is more dynamic and changing. For example, there could be a desert, there could be a mountainous area, there could be a river crossing, and there could also be basically for example, the marshy areas or the dirty areas where, or the cities and the jungle. So as external environment would be changing, so we need to have a different kind of treatment or different kind of protection what we need to provide to the pipeline. So the pipelines, the main threat comes from external, which could be third party damage as well, or the environmental, weather related, or the soil related. But same time, there are internal damages as well applicable. So in general, there are NACE standards. We talk about ICDA and ECDA. ICDA is internal corrosion direct assessment, ECDA external corrosion direct assessment, then SSCDA, which is a sulfide stress corrosion related damage mechanism and direct assessment. So pipeline integrity is practically simpler than the plant, but it has to be managed via the external like a parameter, as the length, the route, or the geography of the pipeline would be changing. So in general, what kind of data, what kind of analysis we wish to do? The first thing is macro analysis. The second one is a micro analysis. When we say macro analysis, means what is the overall pipeline length, how much fluid we wish to transfer, then what kind of material construction we need to have for the pipeline, what kind of diameter of the pipeline we need to install, what kind of welding would be there, what kind of hydrotest would be required. And then if we collect certain data, it would be the CP related data, the pipeline inspection related data, pipeline operation related data. All that data can be checked, but it is called macro and the highest level. But then next could be the micro level. Under micro, for example, if the wall thickness is, and then there could be various surveys. When we say wall thickness detection, mean ILI inspections, direct bell hole inspections, and there could be also other techniques like SIP, DCVG survey, SIP survey, and then there are other surveys like soil classification, soil texture checking, drainage characteristics, topographic surveys. So there are various informations and various kind of data which could be required to be analyzed, which called normally micro analysis of the pipeline. Then another how many threats are applicable? If we try to classify both time and independent of time kind of damage mechanisms, so there are altogether 22 threats. If we see those 22 threats, then first one, when we say unknown, it means there's a mixture of all of the 21 damage mechanism it could be. Then time dependent mean external corrosion, internal corrosion, stress corrosion, cracking. Then resident mean the manufacturing related defects or dormant defects, which are coming defects in the weld seams or the basically base metal of the pipe as well. Then during the new construction of the pipeline, there could be welding, fabrication related defects, if there was defects in the during the welding, and RT was done, and those defects were whether detected, not detected, and those defects could be there. There could be some base metal like lamination in the pipe base material or the quality of the base material. Then there are equipment which are associated with the pipeline like valves, flanges, pumps and compressors which are associated with the pipeline. Those equipment may also have a problem. Then there could be third-party threats as well. If the pipeline is passing by any area, this could be hampered by the neighboring pipelines, or it could be hampered also by any other third-party movement, by drilling, by dredging, or some other reasons. Then there are the incorrect operational procedures or operational conditions. Like these kind of threats can be caused by the inappropriate operation of the pipeline by the operating team. Then there are also weather-related threats, like due to so first of all, soil movements due to earthquake, or there could be also excessive hot or cold weather. There could be also hydrotechnical reasons which are related to which are causing these kind of threats. There's one more, soil movements or land movements, which are geotechnical threats, and those are also causing sometimes problem in the hilly areas. Last but not least is the lightning. It means if it could be impacted by the natural lightning, which is impacting from the skies during the bad weather. And if the earthing is not done for the pipeline properly, it could be hit by the lightning from the skies. Now, this pipeline integrity management system, how it is managed, and then which codes and standards are governing it. So there are big list of code and standards which basically help us to maintain integrity of the pipeline. The important one which are covering the integrity parameters of the pipelines are the ASME B31.8S and API RP 1160. API 1160 is for the liquid carrying pipelines, and ASME B31.8S is basically related to integrity management system of the gas pipelines. The elements or the mechanism of both pipelines, both these standards is more or less same. Both are American standards. First one, ASME, is from like American Society of Mechanical Engineers, whereas the other one is American Petroleum Industry Standard. So both standards basically complement each other. Since we are focusing mainly as a base standard, American standards, so that's why we are referring those. There are certain European standards are also available. Other country standards are also available, and those could be used. But we are not eliminating any one particular standard and not favoring anyone. But the mostly in our region, Middle East, we follow American standards. So NACE is also like another American standard. So there are basically standards related to internal corrosion, external corrosion, and like I referred, ICDA, ECDA, SSCDA, and control of internal corrosion in steel pipeline and piping system, which is SP 0106. Similarly, 0169 is control of external corrosion on underground or submerged metallic piping system, and then SSCDA and ICDA and ECDA are covered by 204, 206, and 502 specifications. Then there are also other inspection standards which are applicable in various aspects, like API 570 is the inspection standard for the piping systems. Then API 571 is related to damage mechanism. API 580, 581 are related to RBI 579. API 579 is related to FFS assessment. API 1163 is inline inspection related guidelines. Then API 14E is related to hydraulic sizing of the pipelines. And then ASME B31.4 and ASME B31.8 are basically design and construction related standards. And first one is for liquid pipeline, and second 31.8 is for the gas pipeline. Then if there are certain defects, then those could be assessed under ASME B31G standard. There are other companies like best practices, various, we are not like specifically naming all the companies, like we're just giving as example, like different companies has also prepared their standards, like ADNOC has prepared the standard what we're referring to, mechanical design and installation of subsea cables, then free span design and recertification of the subsea pipelines, then subsea pipeline crossing design and construction. Then there is specification for hydrostatic testing of subsea pipelines, then basically induction bands in pipelines. These are the basically standard coming from ADNOC, and there are Saudi Aramco related standards, which damage mechanism is A033. Then assessment of pipeline defects is SAEP 306. Then piping and pipeline repairs is SAEP 310. And similarly, there are standards from Petronas pipeline inspection and maintenance guidelines for the pipeline. Those are also available and developed by the company. So what is being stated, like integrity management of pipeline is managed with the help of international code and standard, and companies have also developed their own in-house standards which could be followed. Here, when we are saying the asset integrity management system for the pipeline, the important thing is we should be aware about the boundary limits. Like what are the boundary limits for our typical standard? Like here we are saying this practice, what we're talking about PIMS, is coming from the typical battery limits of the pipeline systems, right? Here, like from one pig launcher to another pig receiver. So these are the boundary, and it in between, basically. Let me close my phone so it's not ringing again. So there, like boundary point of view, we should know like which is covered under this scope. So this like a plant is not being covered, but the pipeline from big launcher to big receiver is being covered under the PIMS scope. So then if we try to cover a little bit like a 31.8S, because managing system integrity of the gas pipeline. So I will ask my colleague to turn off your ring. So it's ringing, Mr. Ati. So the second time already ring. So now this is the standard, like basically if you see, to make you familiar, like a managing system integrity of the pipeline, and then what it cover. The mouse is not working. Okay, just a minute, working. Right. So here, if you see, normal aspects like integrity management program overview, consequences, then gathering and reviewing the integrity data, risk assessment, integrity assessment, response to integrity assessment and mitigation, integrity management plan, performance plan, communication plan. So these are various elements what we need to cover under integrity management program, right? So this is the guideline provided by this standard, and this standard basically applicable both onshore, offshore pipelines, but mainly for the carrying gas pipelines. Similarly, there's a API 1160, which is managing system integrity for hazardous liquid pipelines. And this standard is also more or less similar to basically API ASME B31.8S, but it is presented in a little bit different way, but elements are more or less same. And I will show you the next slide. See, comparison, if we try to make it, so we took the basis of 31.8 as a first reference, and then we have like all the elements listed up to 14 from the topic to the last one, and then we brought into API RP 1160 clauses. So all clauses are basically more or less compatible. It's just for a understanding point of view, if our pipelines are being managed either 31.8S or by API 1160, so both parameters are more or less same. So just for the sake of introduction, like it is not the issue if we follow standard A or standard B. If we follow one, other standard would also be followed. It also means that we don't need to develop a separate system for gas pipeline or another system for the liquid pipeline. If we develop one common system, it would be applicable for both of the pipelines. So now is some more detailed theoretical part is starting. So I know that the topic is more theoretical and it has to be given due priority. So integrity management plan or program of a pipeline is consisting of basically 5 main elements, like a pipeline integrity management plan, performance plan, communication plan, management of change plan, and quality control plan. And these plans are further subdivided into sub-elements, like here. For example, the first element of a pipeline integrity management plan is subdivided into gathering, reviewing, and integrating data, then assess risk, integrity assessment, responses to integrity assessment, mitigation, which is repair and prevention and intervals. So it means integrity management plan is divided further into 4 sub-elements. So here, if we try to see that, like integrity management plan, under element number, these are the ASME B31.8S sections, what we're trying to show here. Then plan framework, which is further subdivided into 4. Then we under performance plan, there are 1, 2 sub-element and second level element. Now, it is a sub-elements under performance are performance measure characteristics, performance measurement methodology, performance measurement infra system, then intra-system, then performance measurement industry-based, then performance improvement. Then similarly, communication plan is there, management of change is there, quality control plan is there. So there are the sub-elements like a process or the activity measures, operational measures, direct integrity measures, right? Now, integrity management principles, it is becoming more theoretical. So when we apply it, it is easy to follow, but here it looks like normal, like a definition. What is functional requirement? For integrity management shall be engineered into new pipeline system from initial planning, design, material selection, and construction. Integrity management of a pipeline starts with sound design, material selection, and construction of the pipeline in accordance with applicable code and standards. This is a functional requirement for the system. Then system integrity require commitment by all operating personnel using comprehensive, systematic and integrated processes to safely operate and maintain pipeline system. An integrity management program is continuously evolving and must be flexible. An integrity management program should be customized to meet each operator's unique conditions. Then information integration is a key component to manage system integrity. A key element of the integrity management framework is the integration of pertinent information when performing risk assessment. Then risk assessment is an analytical process by which an operator determines the types of like adverse events or conditions that may impact pipeline integrity. Risk assessment is also determine the likelihood or the probability of those events or conditions that will lead to a loss of integrity and the nature and severity of the consequence that may occur following a failure. Then performance measurement of a system and its program itself is an integral part of pipeline integrity management program. So if I try to cover the first part, which is the integrity management program in a more theoretical way, so we will be spending some more time, like what are the explanations like integrity management program, the performance plan, a communication plan, management of change plan, and quality control plan as a part of integrity management program elements. So here, the other way how the movement goes in, it is like identifying potential pipeline basically impact by threat, then gathering and reviewing and integrating data, review assumptions used in risk assessment, then if this risk is acceptable, no, if then you go back, if yes, then risk assessment is required, then all threats are evaluated, integrity assessment done, and the response to integrity assessment is basically conveyed and combined. Then other part is what kind of integrity management program we want to follow, whether it is a prescriptive or it is performance based. Prescriptive mean it is like we will be doing this kind of inspection with this interval, and or we have to maintain this kind of program, and we have to do this kind of doses of the chemical inhibition or so on. So prescriptive mean everything is described in a way it should be followed as it is stated. Performance mean, like if we try to specify certain KPIs, let's say we say that if the effluent assessment result will be showing any kind of SRB's presence, then we will be injecting the biocide treatment to the pipeline. Or similarly, if there would be high level of oxygen corrosion, then in addition to mechanical scavenging, we will be doing some kind of oxygen chemical treatment also to remove oxygen from the water. Similarly, if there is a hydrocarbon line, and if there would be weight loss, coupon would be indicating some kind of metal loss, then we will be doing inhibition and so on. So the difference is prescriptive means without looking at the end result, we say, even though that is also correlated, if the end result would also be seen in the prescriptive form as well, but mainly it is defined in the beginning, and then we try to gauge and calibrate it as we go along. But in the beginning, it could be prescriptive, whereas performance-based mean based on the KPIs and certain parameters, what would be followed in the future. Like a performance-based program shall include the following in the integrity management plan. For example, a description of the risk analysis method employed, documentation of all applicable data for each segment where it was obtained, a documented analysis for determining the integrity assessment intervals and mitigation and the preventive methods. A documented performance metrics, that is the time, will confirm the performance-based option chosen by the operator. There's like one thing is also there's no single one method, either it should be prescriptive or the performance. Generally, it is combination of both nowadays. So these two approaches are defined and explained. However, on the actual, generally companies are following the combination of prescriptive and performance-based, basically integrity management programs. Next, like if we try to see processes point of view, identify potential pipeline impact by threat. Like we try to identify the applicable damage mechanisms and application, then areas where these threats are applicable, and how we should be managing them. Gathering, reviewing, and integrating data. It is like a big subject, pipeline when it is designed. It got a big set of documents, starting from the topographical survey, pipeline route, then development of the PFDs, heat and material balance, then pipeline sizing, hydraulic calculations, wall thickness calculations, stress analysis, then road crossings. There are additional thicknesses or additional protection required, overhead bridges, and underground, above ground, like interfaces. So all that data, what we basically use while developing a pipeline, we need to place in a way the information can be made traceable and can be used for various kind of activities what we need to perform. Like risk assessment in general, all of us might be aware, or many of us, like risk assessment is a normal standard process. So how it is done? It is done like if we know what threats are applicable and what the probability of happening, which is like likelihood of happening analysis based on corrosion rate, based on third-party threats or other hazards which could be applicable to pipeline, and then assessment of the consequences of those failures. If a pipeline will fail, what would be the impact on its production, on environment, or the public at large? And then by assessing POF and COF and multiplication of this both, we can basically assess the risk. And then accordingly, if the risk is acceptable, we can operate the line. If the risk become unacceptable, then we may have to take certain corrective action. One thing we all remember that there is in any oil and gas sector or pipeline operations, nothing is risk-free, but we need to operate the pipeline in the ALARP region. ALARP region means as low as reasonably practicable, so as the capital investment is made safe, and also the people who are operating the pipeline or the people who are living around, they are also safe. And similarly, the environment is not impacted by the any like a mal operation of the pipelines. Then integrity assessment means if there are certain defects or there are based on those defects or threats, pipeline risk assessment is done. Once we know the risk, if the risk is becoming on an unacceptable level, then we have to do certain corrective actions, or we have to monitor the pipeline, or we have to change the pipeline even, and if we have to do some kind of chemical treatment and so on. So all these parts where the design aspects, the FFS aspects, and then acceptability of the pipeline assessment is concerned, those are done as a part of integrity assessment of the pipelines. Then responsibility of the integrity assessment, mitigation, repair, and setting inspection intervals. Once we know that like the pipeline condition is known, number two, the threats are known, risk assessment is done, then the next is the who would be doing the, if any repair or remedial action is required, who will do that, and if there would be any follow-up inspection required, then who would be assigned that responsibility. So these all aspects are basically covered under the pipeline integrity management system, where role and responsibilities are defined to various stakeholders of the pipeline. For example, operation would be maintaining, doing their part of the actions, and similarly, inspection would be doing their part of inspections. Due maintenance activities would be done by the maintenance department, and the monitoring department or HSC department will be taking care if there is any additional hazards coming either by operations or by day-to-day work or by following of the PTW system of the basically company. Then once, like as a life cycle point of view, plan, do, act, and then reassess. So here, if we are doing our like a planning part by gathering all the information and the data, the second stage, we do the risk assessment, then we do the planning part to do the corrective actions or inspections or condition assessment of the pipeline. Once we have that action, then we have to basically analyze the data and update the information as it goes. So this is the basically one of the important step, like update and integrate the data what we started in the beginning as a gathering and reviewing of the data. Risk assessment part, like in general, we have covered it, and this is the part of the activity as such. So next, integrity management program point of view, like integrity management plan, no program which comes under like integrity management plan, like how we plan our activity for the integrity management of the pipeline. So there is some repetition of the information, how the standard is basically defined. The integrity management plan is the outcome of applying the process depicted in the integrity management process. Then plan is the documentation of execution of each of the steps and supporting analysis that are conducted. The plan shall include prevention, detection, and mitigation practices. This plan shall also have a schedule established that consider the timing of the practice deployed. The plan shall be periodically updated to reflect new information and the current understanding of the integrity threats. Performance plan means the operator shall collect a performance, like analyze the if whatever plan has been implemented, right? So its effectiveness, whether it's working, not working, that should be assessed. So that is called performance assessment of the plan. Next, communication plan means like if whatever plan is being followed, how the information is being basically shared with all stakeholders. Like for example, the operator shall develop and implement plan for effective communication with employees, the public, the emergency responders, local officials, and jurisdictional authorities in order to keep the public informed about their integrity management efforts. The plan shall provide information to be communicated to each stakeholder about the integrity plan and the result achieved. Then management of change plan. For example, if there is any change, it's the management of change like a procedure. It has to be followed so as if any change in the system is required to be done, it should be done by following the management of change process. In that particular process, like whatever due studies, due cause and effect, cause and root cause analysis, or due engineering and process analysis, if it is required to be done, should be done, so as any change should not be done as a part of basically as a shortcut, or and any detailed analysis should not have been missed. Quality control plan means everything what we do under the integrity management program, whatever we do, quality control and quality assurance is must. For example, if we are gathering information, if the information gathering is not done properly, proper checking is not done on the information, like if the diameter, thickness, operating condition, fluid composition, then the root data, thicknesses, so you name it, all that information what is being filled for the analysis, if that is uh, keyed in a wrong way or gathered in a wrong way, it can have a problem. Similarly, identification of the threads, if they are not identified in a proper order or proper way, then it could have a problem. Then as how the risk analysis is being done, the risk analysis, it should be done by a proper methodology and by the qualified people. If there would be any quality issues, it would also misguide. Similarly, all the assignments of the responsibilities which are basically assigned to various stakeholders, so it has to be conveyed properly. It means that all the steps, whatever we do, QA, QC, quality control and quality assurance, both are very, very important activities to be followed. See, one part, like as a part of the risk, how the consequences can be assessed. Like if any failure may occur in the pipeline, for example, if compressors stop working for a gas pipeline, then fluid will not be reaching to the other end. Similarly, if there is any leakage or any rupture in the pipeline, it can have both environmental safety and the production impact on the pipeline. So these consequences has to be established for all the threats which may be exposed to the pipeline. So what the point is, consequence could be for various stakeholders in a different way, but those are quantified in terms of the effect or impact of any particular hazard or a failure. For example, a potential impact area is a one thing, like how it can be calculated. So if a gas leakage is there nearby any particular school or hospital, if a natural gas carrying pipeline, it may, if the gas is carrying some toxic gas, a toxic element, so it may impact, if it catches fire, then it could also be dangerous. Similarly, if there's a oil pipeline passing by a village or somewhere, if it is leaking and people start coming here and collect the oil, and if sometime there's a fire in that particular area due to some cigarette or some other reason, then many people can be burnt, and it happened in many areas. So it means the consequences of any particular leakage or failure should be kept in mind, and those has to be assessed. See, other than gas, I gave the example also. The formulas are available in the relevant standards, which could be calculated. Right. Similarly, ranking of potential impact areas along the pipeline, if you can see that various diameters can be made, like if the school is coming, how it would be impacted the pipeline, and if it is impacted, then either the pipeline should be shifted away or the school should be shifted away, whichever is being built second time, right? So if pipeline is already laid, then school has to be moved away. If the pipeline is laid after school, then pipeline has to be moved to the area where it can be safe to operate, and it should not have any impact on the population. See, while we are saying like consequence point of view, evaluating, for example, number and location of inhabited structures like a population or the people around the pipeline route, proximity of the population to the pipeline, proximity population with the limited or impaired mobility, for example, hospitals, schools, environmental damage, effect of unignited gas releases, security or reliability of the gas pipeline, public convenience and necessity, then potential for secondary failures, duration of a failure event, including product depreciation and the potential fires. So these all impacts can also be considered during the consequence of the failure if the pipeline might be failing. So now, again, like we are writing again, like gathering and reviewing, integrating data. So today, if you will find, I am touching more theory, because this standard, what we are following to implement the PIMS system, so it carries certain theory. I thought rather than going straight forward to technical matters, some theoretical aspect should also be discussed. So here, like gathering, reviewing, and integrating data. As I said earlier, it is a repetition because what is the pipeline? Is a one pipe which is going kilometers and kilometers. So what could be the supporting documentation? As I said earlier, topographical survey, geographical locational survey, or there could be a GIS data, there could be PFDs, PNIDs, there could be isometric alignment sheets which are showing the route of the pipeline. Then there could be CP system, the CP system related documentation. There could be coating related data, there could be material related data, there could be corrosion related data. So all that data we need to basically align, we need to gather, we need to reorganize and we need to present in a way it can be made useful. Data requirement, we need data for all kind of actions, even let's say for the operating of the pipeline. So we need to have operating manual. And so at this stage, we need fluid composition, operational requirement, like IOWs, integrated operating windows, and how the system can be operated by the operators in a safer way. Then prescriptive integrity management program point of view, if you see that what kind of data is required, generally this data is, if you see here given in the standard ASME B31.8S, attribute of the data mean what we need normally for the prescriptive program. It's not must, it looks like a little bit more theoretical. However, if we go in normal work, you will see in the end, as we will be showing you the PIM program or software, it is not so difficult to organize, but it's saying that what we need normally: pipeline wall thickness, diameter, seam type, and joint factor, manufacturer data, material properties, then year of installation, bending method, then let's say if we're not reading all, field coating, basically methods, then operational mean gas quality, gas flow rate, leak failure history, and then inspection mean pressure test, inline inspection, DCBG survey, direct inspection, and so on. So this is all data you need, both I would say in prescriptive as well as in the performance-based. Then performance-based mean there is no standard list of required data, but to me, performance and prescriptive both goes hand by hand. The similar information which is described in the prescriptive form, you need also for the performance-based integrity management program. So data sources, data sources mean, first thing is the engineering data. When pipeline is being laid, at some stage before pipeline is laid, we have to have engineering work, and that engineering work start from the process design, then it goes to mechanical design, then electrical for the CP system. Then there is also role of corrosion, electrical for the even instrumentation and controls for the SCADA system. So the information sources are there first is from engineering documentation, and engineering documentation goes to at least 7 type of engineering discipline, which may involve structural, civil, electrical, instrumentation and control, process, HSC, and architectures as well, and the topographical survey and so on. So the information sources comes from first from the engineering side, then fabrication records, QA/QC records, NDT records. Then in operation, there could be operational logs and control room SCADA logs. Then there would be inspections, and there could be some failure and some incidents, the event logs we call it, inspection planning and inspection execution, maintenance planning and maintenance execution. All these informations comes from the various sources and various departments what we need to use for our day-to-day work. Then sources as information, one is from the documentation. Then there are world organizations from where we can get some standard reliability data. For example, there is ORIDA, we can get some data from the failure or the basically failure rate or standard reliability data, and there could be some information can be gathered from the API 571, API 570. So those standards also give you certain information what can be used, and there are certain research organizations the information can also be used. So information, the main information comes from the operator or the company itself from its own records, and then we can also get certain data from other sources. So how then data collection, review, and analysis, we need to like I'm not going through all the slides because it looks like a little bit boring, but like as we collect the information, we need to organize in a way which we can use. And like if we have to make some Excel spreadsheet, so we can bring the information of one pipeline in section by section, or there could be various pipelines, the information can be gathered, but the attributes, as we showed earlier, we should know that where we want to add the diameter, where we want to add the thickness, where we wish to add to the material of construction, then fluid composition, toxic component, then the inspection, maintenance, operational, all those historical data can be arranged. And like if we want to organize like metal losses by ILI survey or by direct basically wall thickness surveys. So with the by having that data, and if we have to make like a minimum thickness requirement, and wherever thicknesses are more than like lost more than the acceptable limit, then we may have to take certain corrective actions. So those all positions can be shown by the analysis of the data and by the review of the data. Data integration, as I said earlier, like there could be various surveys like a wall thickness measurement by direct measurement by ILI. There could be some CP surveys. There could be DCVG and SIP surveys. And if we try to overlap all these surveys, it may show us wherever the metal losses or defects are coming. Maybe at the same location, the pipeline is unprotected or underprotected from the CP system, or there could be some damage of the coating and which is causing high corrosion. So then the repair on the CP system, repair on the coating system, so as external corrosion can be prevented. Similarly, if somewhere we have an efficient program, if that is not so effective, maybe corrosion is coming from the internal side, and if we need to take certain corrective action can be taken. So overlapping of various surveys and their results, and then interaction or the causes coming to those problems from one side to other side can also be understood and can be analyzed. So here, like as you said earlier, like a manual integration and graphical integration both. So if we see the pipeline passing by certain area, and if any high consequence related population or school or hospital or any mall is coming nearby the pipeline, that can be seen on the basically a graphical form, as you can see here. And then there could be a quite like a action which could be required to be done, either movement of the school coming which is coming in that facility afterwards, or the pipeline, if that is coming afterwards, should be moved away. Now integrity management program, if I go to the next part, like that is the same program and basically process. An integrity management program provide a way to improve the safety of the pipeline system and to allocate operator resources effectively to identify, analyze actual and potential precursors, events that can result in pipeline incident, and examine the likelihood and potential severity of the pipeline, provide a comprehensive and integrated method for examining and comparing the spectrum of the risk and risk reduction activities, provide a structured, easily communicated way to selecting and implementing risk reduction activities, establish and track system performance with the goal of improving that performance. So basically, if you see here, the program carries 5 steps. Identify, analyze the actual and potential precursors, like what may go wrong. Then establish the likelihood of that, then establish consequence of that. Knowing the risk, we can develop the basically comprehensive integrity management program, whether inspection, whether maintenance, whether operational control, whether any kind of corrective actions that can be done. And if those corrective actions or the corrective or integrity management program is rightly conveyed to the all stakeholders as applicable, right? Then once the plan is implemented, then we try to also establish if this plan is effectively working or not. So now, as a PIM, like how this system is established. So just to let you know, we will have a break once I will be completing this theoretical part and before the case study. And under that break, we will be having question answer session. Please keep writing your questions in the chat box, or question answer, right? So as you are ready. And what we will be doing, we will be calling the person who wrote the question, and he will be given a chance to read his name and location and company. Then he would be able to ask his question and we will be answering. So in this way, we will be trying to make this process as more interactive. So here, if you see, the triangle is there, it got four layers. Like first is the AIM system, Asset Integrity Management System. So what we are saying here, the PIM system is not independent of AIM system. It is the sub part of the AIM system, AIMS, Asset Integrity Management System. Then there is a Pipeline Integrity Management System. Under that, there are operational manuals, procedures, and inspection and maintenance procedures as well. Then data collection, review, analysis, and PIM software. So PIM software comes at the end. So this is the pyramid where the PIM system comes in. So all the discussion what I have had till now, every inspection engineer or pipeline engineer do not need to follow or do not need to remember it. It's just a theory, like how the system is built on. Then when we try to basically cover the pipeline life cycle, so we should know that there's a design integrity, then there's a technical integrity, then operational integrity. As such, there's an asset development phase, which is when the design, procurement, construction, installation, and commissioning phase, and then there's the asset operation phase. So in a way, the PIM system should be able to cover the complete, basically, I would say, the life cycle of the pipeline. So, for example, concept, design, procurement, construction, commissioning, operations, inspection and maintenance, mothballing, and decommissioning. So these all aspects are required to be managed under the PIMS program. So it is like, this is easy part. The previous part, what I was trying to explain, even I say gathering information, is not so difficult. Then number two is the risk assessment. Number three is the development of corrective integrity management program, then assessing the integrity management program and applying it, and the lesson learned. So life is simple, it's not so difficult as such. But here we're trying to see what is the life cycle of a pipeline. So life cycle of a pipeline covers, start from the concept, then to design stage, design engineering, procurement of the material, construction, and then commissioning, operations. Then while plants are in operation, we need to do some sort of inspection, and we also need to do some preventive maintenance. Then if we want to basically retire the pipeline, or we want to keep the line off for a certain period, then we should do mothballing. And if we have to decommission and uninstall the pipeline, there is a decommissioning process. So these are just life cycle of a pipeline. Then under that, like how the life cycle goes, cycle point of view, we have like first is a concept here, then design, build, procure, commission, operate, then corrosion control, if the corrosion damage mechanisms are there, then inspection, then maintenance, then if there could be change or abandon the pipeline. So this is the life cycle. We can go this way as a closed cycle, or we can go as a previous, which is a state pipeline. So both indicate the life cycle management of a basically pipeline. Now here, how it is managed. So is a documentation system. Like here, we got about 17 system under the AIMS, which is Asset Integrity Management System, Pipeline Integrity Management System, the Emergency Pipe Repair System, SCPC Management System. SC means Safety Critical Equipment Management System. PEMS is Pipe Pressure Equipment Management System. PMS means Piping Management System. PSV is MS. SIMS means Structural Integrity Management System. Lifting Equipment Integrity Management System. Inspection Management System. MMS is Maintenance Management System, or your CMS or SAP or Maximo. Then there is also AOIMS, mean Asset and Operating Integrity Management System. Then so on. So these all basically various documented system. The PIMS is one of those. PIMS is one of those. And it can also be seen this way. And then there's a platform how the systems are basically linked into the AIMS system. Here, if I wish to show you, like AIMS system means what? The AIMS system carries the same life cycle, Asset Integrity Management System, then BC Management System, Then there is a electrical equipment integrity management system, pipeline, and so on. So under subsystem, these are the basically part of AIM system. After AIM, there's a PIMS framework and manual. Under that, if the same way as we see in the API 1160 or we go ASME 31.8S, these systems are there. For example, introduction, company PIMS policy and objective, company organizational structure, PIMS organizational chart. Then there is a, for example, life cycle point of view, design, integrity, concept design. Then there is also other stages, operation, and basically other like a stage inspection, maintenance, same stuff what we have been discussing among. This is covered as a part of the basically PIMS program which company would be adopting. Similarly, pipeline operating manual, for example, if a pipeline is, this is a normal operating procedure or operating manual of the pipeline. And here, like HSC related or as per OSHA standard, the operating envelopes how to shut down the start of the pipeline, how to shut down the pipeline, how to isolate the pipeline for maintenance, normal operations, upset operations, and the pigging operations. So whatever operations are required as a guideline for the operators, this procedure provides that guideline. Yes? Yeah, we will go after completion of this basically, right? There's question when question answer coming, right? Yeah. After maybe 4-5 slides, we're going for question answers. Then here, sample list of inspection standard operating procedures and SOPs. Here, like there could be number of basically SOPs as a part of inspection. There could be 100 sometime. Like here is the inspection cathodic protection and monitoring guideline. It could be eddy current inspection. There could be a, for example, pipeline UT thickness surveys, RT surveys, CP monitoring system procedures, and so on. So there are various procedures which are applicable. For example, pipeline pigging guidelines, piping inspection procedures, and so on. This is one of the SOP for inspection. For example, pipeline integrity management program. It is coming pipeline current mapping procedure. So if a pipeline current mapping procedure, so this one procedure and it would be its content. So those procedures are also required as a part of PIMS program. Here, there are sample list of maintenance standard operating procedures for the pipeline. There could be for various maintenance activities. There could be a requirement of the maintenance procedures, and those are also sometimes 50, 60, or 70 procedure applicable. And whether like these could be the pumping station or compression station related equipment where, for example, even fin fan cooler is applied on the downstream of the gas compressors and heat exchangers also. So it may not be direct pipeline, but it could be the like a terminal where the compression stations are involved. And if there is a firefighting system, so all those valves, which could be isolation valves and so on, we need to have some sort of maintenance guideline, which are also prepared. So everything is being documented as a part of PIMS program. So this is the example, like is a maintenance procedure for like one of the tanks and the feed pumps. There's also like one other example, pipeline repair procedure coming for. So how the pipeline can be repaired in emergency. So these procedures are also prepared. So when any kind of repair application is coming, so it is not taken as a surprise, and we should not be making any mistake during that hurry, and so as everything is done in a proper order. So before I go to the software side, that I will start after this detailed question answers. So Ms. Adeline, can we go to the question answers, please? I know that we have covered almost 103 without break. It could be quite boring. So, so it's okay. So please, you can ask the gentlemen so as we can make them part of this discussion only. Speaking, they can also speak. So let's give the floor to the Mr. Mohammed Ali Shah. If you can introduce yourself and ask question.
Please raise your hand, Mr. Mohammed Ali Shah.
If not, then I can read his question on his behalf. His question is, can API 1160 be applicable for natural gas as well or for gas only? In general, API 1160, answer is that is for the oil pipelines, and ASME B31.8S is for gas pipelines. But what I said earlier, if we develop one system for gas, similar system is applicable on oil as well. So as such, we don't need to produce two systems. Both systems are basically interconvertible and can work jointly, right? Similarly, other question is Muhammad Shah also asked, I can reply now. He said, what is the difference between API 580 and 581? API 580 is RBI standard, whereas API 581 is a basically recommended practice. And that is basically how the qualitative, semi-quantitative, and quantitative RBI can be done. There is a difference between the scope of API 580 and 581. Okay. Any other question?
Hello, Assalamu alaikum. Rao Sahab, can you hear me?
Yes, please.
This is Mohammad Ali Shah. Actually, I work in SSGC, and one of my, you can say, the job is to work on the pipeline integrity management as well. So I have been engaged.
Mr. Mohammad Ali, you are away from your mic. If you can come closer to your mic, please.
Now can you hear me?
Yeah, it's better now.
Okay. So directly coming to the question, my first question is, ASME B31.8S, is it applicable for the distribution network as well? As you know, the distribution network is mostly on P, and it's completely on laid down the urban cities or the towns where people also live. So how the ASME B31.8S?
I'm sorry, I'm unable to hear your question properly. Maybe there's a sound system problem at our side or their side.
But I don't know, maybe there's a sound issue or some sort of internet connectivity issue. Just I'm asking, is it applicable to the distribution network as well, since it is in the populated area network, and it is mostly the PE network, not the ferrous material. So yeah, or it is only for the transmission network.
Okay, so Mr. Muhammad Ali, API, sorry, ASME B31.8S is applicable for the complete gas network, whether it's transmission or distribution.
Right. Thank you.
Okay, and the second question I already replied. API 580 is a standard, and API 581 is a detailed recommended practice.
Next question.
Yeah. Good. Next question.
Muhammad Omar.
Muhammad Umar, can you give the chance to him so he can ask his question?
Please raise your hand, Mr. Muhammad Omar. Mr. Muhammad Omar, please raise your hand so we can give you access to speak.
So I can read the question, like what is the difference between onshore and offshore pipeline management? So I can reply, see, the system for onshore and offshore is same, but the threats or the conditions which are applicable on onshore and application on the offshore are different. So when we have to identify threats, those are identified in accordance with the applicable condition of the pipeline. Okay. Next question.
Mr. Shahabuddin, please unmute yourself and ask your question, please. Mr. Shahabuddin.
Okay, looks like either they are unable to listen us.
They can hear us.
Or they may not be there. Okay, right. So here, see, question is, how does the PIMS approach anomaly detection, assessment, mitigation, and considering the criteria set? PIMS program, like it is like any integrity management program. The first thing is like identification of the basically threats and carrying out inspection with respect to applicable threats or damage mechanism. And if the anomaly is basically shared or found by the inspection team, that anomaly assessment or defect assessment is required to be done. And then if defects are within unacceptable range, then certain mitigation action is also required to be taken. So it is a part of the pipeline integrity management program. We'll show you in the software demonstration where it is also part of our working process. Next question, please. Finally, I replied that I said 31.8S is for gas pipeline and API 1160 is for liquid pipeline. but the elements are common. If we develop one system, it can cover both gas and liquid pipeline, but this standard cannot be cross-used. Okay, next.
Next is Mr. Ashik Farhat. Please ask your question.
Hello, Mr. Ijaz. How are you? This is Ashik from Pota Fujairah.
Yes, sir. Please go ahead with your question.
Yeah. So can you know what are the documents like data, plant data required for the inline inspection during the data gathering phase?
See here, Mr. Ashik, if the pipeline is requires some sort of ILI inspection, so the first thing,
especially during the time of intelligent picking. I mean, can you hear me now?
Yes, we can hear.
Okay. So my question is, what is the data requirement for the inline inspection, especially for the intelligent picking during the time of data gathering phase?
See, if I understood your question rightly, right? You're saying what plant data requirement for inline inspection during data gathering phase? See, for this, if the line got 5D bends, if all T's are barred, pig launcher and receivers are installed. So these are the three main requirements for us to do the pigging. Then next thing is what kind of technique is required to be followed. For gas pipeline, mostly MFL technique is preferred, and for liquid pipeline, you can do UT, right? So this kind of checking should be done only separately because, okay, Ali, the checking should be done properly. So I think Mr. Ashik, I replied your question. Let's go to next question so as we are not losing the interest of the people. Go next question quickly.
Mr. Hussein Imam, please ask your question.
Sir, I am Hussain Imam from Gwadar Port. I just want to clear my question that ASME B31.8S is for the general normal gas pipelines can be used like from main source of SFGC to our home, or it is mandatory for the the pipelines between the countries.
Can you please repeat your question one more time? There was some interruption in between.
I'm just asking that this ASME B31.8S is used for the normal pipelines, gas pipelines, which is connected inside the countries like from SSGC to our home, or it is for mandatory for the connections between the countries.
No, see, ASME B31.8S is integrity management for the gas pipelines and networks. So it covers both the complete SSGC, SNGPL gas network pipeline and piping distribution network is covered under this standard.
Okay, thank you.
Thank you. And there was other question was if any gas pipeline is 3,000 kilometer is damaged from two different locations, how we will get the exact approximate location? See, these locations are either reported by ILI or by direct measurement. PIMS system is there to identify these locations so as the due attention can be given. The PIMS system does not identify the location of the defect itself. The location of the defect is identified by the robust inspection and basically survey program.
Thank you very much, sir. Thank you, sir. Boss. Thank you.
Our next question from Mr. Noman Yusuf. Sir, please read your question. Mr. Noman Yusuf.
So I can read the question: how war attack or insurgent attacks to disturb or halt the supply is integrated in the plant. See, like there are areas where like soil movement or land movement can take place. There are areas where there are insurgent acting in certain region of the any country or the world. So right of the way, ROWs are basically protected, or there could be some sort of like walls or barricading or the certain safety precautions are taken, or the security forces surveys are taken, or ROVs surveys are taken, or remote like helicopter surveys are being followed, so as if insurgents are there, they could be neutralized. So, but these areas are basically identified in the PIMS program or software, where we know that from this coordinate to this coordinate, from this region to this region, we have a potential threat coming from the third parties or insurgents or maybe terrorists. So there could be a certain corrective action program which is required to be taken, and more effective monitoring by air surveillance could be done. Next question.
Our next question is from Mr. Kazi Ghulam Mustafa.
See, what is the minimum frequency of pipeline inspection, especially ILI? So there's no specific basically identification of like any frequency. However, depending upon the service of the pipeline, sometimes cleaning pigs are required to be run to clean the pipeline so as the pipeline is not affected by any settlement of the fluid at 6 o'clock positions. Sometimes for gas pipelines, if there is any source service or we are expecting any high external corrosion damage mechanism, then there could be a frequency of the intelligent picking at the quicker level. In general, there is no specific rule, either 3 years, 5 years, 6 years, or 10 years in interval you need to do ILI. ILI effectiveness is also a questionable inspection. So I am not personally, I am not basically the fan of ILI, and we have reviewed like many places where the ILI results are not so reliable. So the more effective inspection is direct measurement, and maybe on the sample level, DCVGs, SIP surveys. So those are more and sampling of the fluid coming out of the pipeline. So direct assessment and direct ICDA and ECDA exercises are useful. Next.
Next question, Mr. Parag, please ask your question.
Good evening, sir.
Good evening.
Yeah, sir, I want to I have the one question that for this performing pipeline integrity audit, any specific training is required or
see, whatever is integrity management program you are following. If you got a AIMS program, AIMS system, PIMS system, then associated procedures and plans what you are executing. In audit, you mostly confirm that those plans are being executed and results are being analyzed, right? So in a way, as such, you audit for the same system what you already defined and put in application. So for that reason, any senior engineer who is familiar with that particular system can go and do this audit.
Okay. Thank you, sir.
Right, thank you.
Next question, sir, from Roderick Mercado. Mr. Roderick Mercado, please unmute yourself and ask your question, please.
Can you hear me?
Yes.
Yeah, my question is after the ILI inspection, what is the inspection technique are the best for verification found in ILI pigging?
The important is the UT scanning or UT gauging, right? If any defect is being is reported by ILI, UT scanning can be done, TOFT and PAUT can be done. So 3 techniques: UT, PAUT, or TOFT. 3 techniques.
Okay.
Right.
Okay. Yeah,
Thank
thanks.
you. Thank you.
Mr. Kazi Ghulam Mustafa, please unmute yourself.
Sabi kasi sama ko.
Mr. Kazi Ghulam Mustafa.
So Mr. Ghazi's question is: the life cycle of a pipeline shall also include protection we provide such CP, coating, CA injection, etc. Yes, answer is yes, because the life cycle means the complete aspects from concept to the final to decommissioning stage. So in between, if CP system is losing its credentials or its effectiveness, the repair would be required. If coating is damaged, then external corrosion could be more there and CP may not be effective. Similarly, if there is any chemical inhibition or chemical injection is required, biocide treatment injection is required. So these all treatments are part and parcel of the life cycle management of the pipeline. Other question?
Yes.
Mr. Madan Raj.
Please unmute and ask your question, please, sir.
His question is, I think, regarding isolation, basically isolating flanges, which are installed basically. Mr. Madan Raj, are you there?
Yes. Hello. Yes, sir.
Yes, sir. Yes, sir.
Sir, actually I need the brief explain for the monoblock and the
CP
about the
server for the
monoblock,
pipeline.
the CP,
See,
cathodic protection.
See, monoblock, normally we call it also like isolating flanges, right?
Yes, sir.
Like if underground piping system is protected by CP system, and there's an above ground portion. So to avoid leakage of the current or potential, isolating flanges are installed, so as the underground and above portion can be segregated. Similarly, the CP is normally cathodic protection, which is like where we have provided electric current to compensate the loss of electron of the pipeline due to corrosion. So the CP is basically compensation by artificial electric supply. So that is the system basically, and the CP itself is a big subject, and that is covered in separate over basically a webinar. Next, please.
Next question, yeah, Mr. Marimutu. Please unmute yourself and ask your question, please.
Yes, Mr. Marimutu.
Sir, what is the difference between MAOP and MOP in pipeline, sir?
See, MAOP is maximum allowable operating pressure and maximum operating pressure, right? Allowable yes, mean that is like you have a pipeline design and wall thickness. So whatever the maximum design pressure of the pipeline, where the pipeline can be operated at maximum, that is called maximum allowable operating pressure. And maximum operating pressure is the how much pressure can be generated by the compressor or pump in the pipeline while normal operation. That is called a maximum operating pressure. We mean that without closing outlet, because if we close the outlet, the maximum pressure which can be generated by a centrifugal compressor or centrifugal pump, that can be defined as a maximum allowable operating pressure, and there should be a PSV which should be installed in the same system. So above that pressure, if it comes due to thermal expansion or other reason, then PSV should be lifted. So the PSV set pressure and MAOP are standard are similar pressure, whereas operating pressure is the maximum operating pressure where you wish to operate the pipeline. I hope it is clear to you.
Thank you, sir. Thank you.
Thank you.
Next question from Mr. Muhammad Jamshed Akhtar Khan. Please unmute and ask your question. Mr. Muhammad Jamshed.
Jamshed sir, like his question is, after hydro test, when some water is inside and line is not completely dried, we can perform inline caliber survey. See, when you are running any tool inside the pipeline, you need to push the tool by some nitrogen or some air, whatever the tool mechanism you will be using, right? And at that time, generally, MFL tools are in the dry pipeline and the gas pipeline, because we don't wish to have a liquid inside the gas pipeline, which could be problematic afterwards. So in general aspect is, hydro testing time is at the new pipeline stage, and ILI running or the caliber survey is done once pipelines are in service after a few years. This is what my understanding is. My understanding could be wrong, but in general, that is the concept what I remember. Next, please.
Next, another question from Mr. Muhammad Ali Shah. Please unmute and ask your question, Mr. Muhammad Ali.
Yeah, hello, Rao sir. My question is again related to the distribution. As you know, in Pakistan, distribution, there's no dedicated corridors for utility. So, my again question is, how we can apply ASME B31.8S in distribution network when it is within the city. We cannot move the houses or the resident of the people if there's a chance of the pipeline burst or something. Then how?
Sir, here,
and 80% of the network is PE, not the ferrous material.
Yes, yes, sir. Here in UAE also, where we are based, There is also a gas distribution network up to the different houses. Similarly, in Europe or America or Brazil, there are distribution networks. But the principle is there is a high pressure transmission network and there is a low pressure transmission network, right? A distribution network. So based on those pressure derivatives, these mechanisms are basically applied. And there's also, if you can remember, the order is added also if there would be leakage of a gas, it can be detected, and then gas authorities can be called for the repair and those corrective actions. So the ASME is applicable, and there are mechanisms which are being applied. Even SNG, SSG is following that. But still, this system is meant to manage both the high pressure and low pressure distribution networks.
Sir, from Mr. Selva Kumar, please ask your question, sir.
Yeah, I can answer that for you. Yeah, Mr. Selva Kumar, can you please go ahead?
Yeah, my concern is if the pipeline is buried, we don't have any data to trace the line. Is there any special equipment to trace the line where it's going underground?
See,
or
yes,
there are
yes, please. Go ahead.
Yeah. Continuation to the first question. Second question is there is any particular inspection technique to check that surface to air interface condition of the pipe? Any particular special technique?
See, first of all, if we got a pipeline asset, right, which belongs to our company, right? So the importance is we should know its route. Number two, it should be protected against external corrosion, mainly by coating and effective CP system. It is a metallic structure. So somehow we should know about the location. If you don't know, then it is like a sort of surprise for the company because my asset is not traceable. So to trace pipeline, the metallic detectors are there, and then the pipeline can be digged out and can be re-verified if the location is there. So it means that the detection methods are there. Secondly, it is a highly unexpected. If my big pipeline or a small pipeline, if we don't know its location and traceability, it means we have a risk. The pipeline can fail anytime. If it is hydrocarbon containing pipeline, it carries the risk of hydrocarbon leakage, which can also lead to a fire or explosion. So it is very important to identify the location of the pipeline and to establish a proper integrity management program. Secondly, at the air interfaces, generally it is a weak area where mostly you have to have special sleeves or special coating to protect that corrosion at the air interface or the soil to air interface. So you may have to dig out a little bit like a soil, like 2 feet down, and then you can see measure the thickness either by UT or by any other alternative technique. So that is the technique can be applied to see the actual health of the pipeline. Remember, it is a normal inspection technique. There could be a modern inspection technique, an advanced one, but the basic and good one is still the visual inspection to see the actual condition of the pipeline if we can basically unbury the pipeline and can look at it. Any other question can ask?
Thanks.
Okay. Thank you, sir. So now we resume our presentation, and now what we'll be showing our what is the software, how this information is basically presented. So now what we covered so far, what is the pipeline integrity management program, right? And what is the basis to develop integrity management program? And then what are the basic elements, right? And those elements, how we understand those elements, and then data gathering or the risk assessment, integrity management program, then performance assessment, prescriptive versus performance-wise, and then how the information is used and relevant. And then we also try to show you the PIMS, AIMS system documentation, PIMS system documentation, then inspection-related SOPs, maintenance-related SOPs, operation-related SOPs, right? So, it is not like only whale plant, which is a Velosi software which can be used. There are other softwares as well which can be used, is based on your choice. So we have both PIMS program, both onshore and offshore site. Why we are keeping two separate softwares? Basically, because there are different conditions, different external conditions mainly for the offshore and onshore. So that's why we have kept these two software separately. It goes start with the dashboard and the basically hierarchy of the pipeline, and on the hierarchy of the pipeline side. So we have here, it's okay, spare time, no problem. So like a pipeline hierarchy and location, and then there is a remnant life, risk, inspection and PM activities, corrosion rates, inspection work orders and bad actors, failure and replacements. So all this information can be seen in the system. Then here is the normal inspection, like a pipeline data, basic data, like summary, system boundaries, system interactions, then system description and system design. So it also carries basic data, operational data, profile data, and pipeline layout and basically specific data. So then we go to the basic data. It also carries various elements under basic data, like service, age, dimensions, material, design, position and basically positioning system, then corrosion protection, primary protection, secondary protection, isolation, cathodic protection features. Then we also have the next is operational data. Under operational data, there are various elements like under general composition, chemical injection, monitoring and maintenance. So here under general service, chemical injection, inspectability, pressure, temperature, this information is there. Then under profile, we have the various design, flow and so, the operation temperature, operating pressure, design pressure, operating temperature, design temperature, material of construction, diameter, and the route related information also. I will show the live demonstration of the software also as the slides are over. So I'm just trying to show you, what features are there in our PIMS program. Like next is like in the pipeline side, section of the pipeline, various sections where the conditions are changing as per the applicable condition of the route of the pipeline. Then there are the crossings. If the road crossing is there, a railway crossing is there, river crossing is there. Then there is also like various surveys or inspections, what we do that, how we store them. Then it is like one of the like ILI result data, how the, if you see the at various route of the, along the route of the pipeline, what the metal loss is, it can be seen also. Same. Then it's the overlapping of various surveys, like inspection survey results, like if it is a DCVG survey, chip survey, or basically another survey, if we have to overlap the results, we can see how is the impact on these surveys on each other. Then is a bell hole inspection, the metal loss, that data can also be recorded. It's one of the screen there. Then a pipeline sections again is like a pipeline assessment, and each section, whatever the damage mechanism is applicable on them. So it is there, what we are showing here. Location from and the section risk also is there. The damage mechanism is applicable on each section. So here, thinning, cracking, third-party potential vandalism is there, and weather related outside the like forces, floods, and so on. So the potential risk assessment is done for each kind of the threat or damage mechanism. So here we assign the POF values based on the corrosion rates. This is the basically consequence of failure, right? No, corrosion rates as per the basically theoretical, basically corrosion rate as per the applicable damage mechanism. This is the erosion related damage mechanism and corrosion rate. This is a consequence level 1, level 2, level 3. We have both options available. Then this is another health and safety, environmental, basically consequences. Then this is the overall presentation of the risk in terms of like for each particular section and their applicable damage mechanisms. So here the demonstration of the how the risk is changing with the route of the pipeline. Then next inspection, when is the next inspection to be done based on the current condition of the pipeline. Software is able to give you the next inspection plan based on the remnant life, based on the risk of that pipeline and the past inspection confidence. So this is the detailed inspection plan, what we use for the develop as a part of basically the RBI analysis. So this is the defect assessment for each defect in accordance with 31G, and MAOP is defined if the defect is within acceptable range or not acceptable range. So here is the basically assessment results of the pipeline, whether the remnant life is within acceptable range or not. So this concludes basically our presentation. So if I have to show the live demonstration of the system, can you show that? And then if there's any more questions, or we can basically say goodbye. But we'll be demonstrating our software. I have to take the control from my side. Yes, sir. I'm controlling. Okay, can you give the control to me? Okay, you can. The pipeline, right? There's some issue on this side. I'm unable to see that. Okay. Let me control. Okay. Okay, right. Now here, if I see the pipeline onshore and offshore, if I go, let's say, onshore side. So here the pipeline, and it's going from one area to other area. We're showing client. No? Which one do you want to use? This is general. Okay, same. Onshore. So this is a live demonstration of the system. So we'll change the client information. So any pipeline area. So this could be our dashboard. Then under form view, you want to see any pipeline which are the remnant life is this. This is a pipeline. Okay. Anyway, since data is changed, so there's some history issue here. So history surveys goes here, and inspection data comes here. Then we have the defect assessment, metal loss, same assessment is there. Location point of view, so some data is empty, so I have to conclude the discussion now. Then pipeline assessment, empty, totally empty. You didn't check it. Okay, before coming in, please check. It's totally empty data. We have the general pipeline client data is changed. Please check before come to demonstration. But we could not show that up here. What are seeing it? We cannot show. Okay. Anyway, IOWs and then inspection data. So this system is there, but what I wanted to conclude, we have a system, but we could not show the client data. It was not changed. So some weakness at my side. So, but however, the information is there, the system is there, and what we showed you in the demonstration is a live demonstration of the feature of the same system, but without client data. Okay, so now let's go to the last part of the question answers, right? Right. Okay, go back to the questions. Mr. Stephen Gyan, can you please ask your question? Mr. Stephen Gyan?
Hello.
Yes, sir.
Yeah, please, I want to ask about a pipeline integrity plan. How do we set it up? Let's say you are in an organization and you want to embark on the setting up of integrity plan. How do you go about it?
See, this is the whole presentation what we made. So it is all about the setting up of the inspection integrity program. First of all, the organization in the company. Number two, the documented system, which involve AIM system, PIMS system, then SOPs for inspection, SOPs for maintenance, operation, and then PIMS software. And then you gather information, you try to identify all the damage mechanisms and threats, and then you try to develop the inspection program. So that is the whole, my whole presentation is like how to set up pipeline integrity management plan. So you need to go through the full presentation what we have given today, and then you may also refer API 1160 or ASME B31.8S, and it can give you the complete guidance.
Okay, yeah. Please, can you display a sample of it for me to see how you can initiate the process?
See, go back again to let me show my presentation. See here.
Okay.
So it is going from the design stage, right? Then procurement, construction, commissioning, operation, inspection, and maintenance, up to at least inspection and maintenance. So step number 1 to this step, inspection and maintenance. So the whole lot is there. And how you cover it? You cover it under life cycle, right? So then document-wise, aim, system, and framework you need to develop. This is like looks like this. Then you need to develop SOPs, PIMS program. Then this is the PIMS manual. Then there are operating manuals for the pipelines. There are inspection procedures. Then there are maintenance procedures. Then repair procedures. Then PIMS software comes. So this is the way you implement PIMS program.
Okay, I'm good.
Thank you, sir.
This one is highly educative. So
right.
yeah, thank you very much for the enlightenment.
Yes, Mr. Aga Sangres Khan. You want to ask Akila Zainal, right? Yes. Okay, Akila Zainal, Miss Akila Zainal, if you want to ask this question.
Please unmute Mr. Akila, so you can ask your question yourself.
Okay, I can answer the question. What is the best method to inspect inspection of flexible riser with certain contain dry gas? Problem with the flexible riser is there's no effective inspection program because flexible riser is not made of solid steel. It is a mix of non-metallic and metallic components, and only visual inspection is effective. And unfortunately, there is no effective inspection program which can be followed for the integrity assessment of flexible riser or non-metallic pipe. Non-metallic pipes or non-metallic flexible risers also. Because like as per our experience, there is no effective inspection program other than visual inspections. Because no entity technique can be applied. Hydro test cannot be done because the riser is already in operation. Okay, go to next question.
Next question, Mr. Aga Sangreas Khan. Please unmute and ask
Mr. Aga Sangreas Khan, if you would like to ask this question, please go ahead. You can unmute and ask your question.
Mr. Aga Sangreas Khan.
So if he's not there, I can read the question. How can a robust health and safety and environmental framework be effectively integrated into pipeline system, mitigates risk and ensure that well-being of both personnel and assets? So practically the elements in the asset integrity and elements in the normal HACMS, there are many common elements. So if we are following HACMS and AIMS program, basically you need to have two separate programs, but both programs and their especially the asset integrity and the process safety are combined one. AIPS is nowadays terminology being used. AIPS means Asset Integrity and Process Safety Management System. So both systems work hand in hand, but there are some common elements and there are some specialized technical details which are not covered under HAC. Those has to be covered under AI program. Okay, next.
Next question from Mr. Hussein Imam. Please unmute and ask your question, sir.
Yes, I just want to know, it is a separate from this webinar. I just want to know if we can do the welding work on the any fuel tank, that is for the liquid or the gas, by filling water in it and do the outside welding. Is it allowable or not?
See, in hydrocarbon live vessel or pipe, the concept of hot tapping can be possible, but there are many restrictions which could be utilized. But that hot tapping concept on any hydrocarbon service in tank or vessel, it is a totally completely prohibited, should not be done. On certain pipelines, the hot tapping connections are allowed, but there is a API 11 some standard is there which has to be followed strictly. And now, when it comes to emptying the tank, right, and filling it with water, making sure there's no hydrocarbon, like if by purging, by emptying the tank from the hydrocarbon, then repair is possible. You don't need to fill water, but it has to be make sure there is no hydrocarbon inside the tank. If there is no hydrocarbon inside the tank, then repair of the vessel or tank is possible.
Like
Let me give example. Like in the vessels which are internally inspected, and that inspection is done after PTW system and followed. Like the vessel has been emptied, then cleaned, purged, and made sure there's no hydrocarbon gas. So as a follow-up of inspection, if there is some metal loss, weld overlay is done internally. It means that kind of welding is acceptable. Same is the case here. If the tank is completely empty, free from hydrocarbon, you don't need to fill the tank with water because it will put a load on the tank, and you don't want to apply heat to the vessel when tank is carrying any particular load, because that load or pressure may cause a failure in the welding zone. Because remember, during welding, the metal is very soft and it may not be able to bear the pressure from the inside. So if a repair is required to be done, it should be done by following the PTW protocol and criteria. But by filling the water and then repairing it, that could carry a danger of failure.
okay, sir. Thank you, sir. Thank you very much.
Thank you. That's it. Any other question? Okay, right.
From Mr. Abdullah Ansari, please unmute and ask your question, please. Mr. Abdullah Ansari.
So I can read the question, Mr. Ansari. What is the inspection technique for underground pipe coating for determining the health itself? DCBG and SIP surveys are the indirect tools to be used to check the condition of the coating system. And if there's any anomaly, then by direct well hole, the conditions are checked as a part of follow-up inspection. So that's it. So we have answered most of the questions. So I know today's presentation was a little boring because more theoretical. I hope it was beneficial for the listeners. And if there's any further follow-up question, please feel free to contact us. And by then, bye-bye, and we look forward to meeting you over next webinar after 4 weeks. Thank you. Bye-bye.